On the back side of the worksheet, we get into some word problems. The word problems are exactly like the problems we previously did. We just need to decipher the clues at the start to get it in a form that we can use. So the prompt begins, use the following to answer questions 11 through 16. The average wait time to see a doctor at a local urgent care facility is 24 minutes with a standard deviation of 7 minutes. We want to write those two main things down and make sure they're labeled properly. Average wait time is the mean wait time, 24. Standard deviation is 7. Now that we've pulled those pieces of information, we can try and attack the individual questions. The first question says, what's the probability somebody waits less than 15 minutes? Another way of saying this is, what's the probability that x is less than 15? So when we go to set up our z-score, we put 15 in where x goes, minus the mean of 24, divided by the standard deviation of 7. Again, I'm going to go to my calculator, making sure that I do the subtraction on top first, then do the division. So 15 minus 24 divided by 7 gives me negative 1.2857, which I'm going to call negative 1.29. I go to my table, I look up negative 1.29. It gets me to a p-value of 0.0985. Because it's a less than question, that is the correct answer, 0.0985. Next question says, what's the probability we wait more than 30 minutes? Z equals 30 minus the mean of 24 over the standard deviation of 7. Again, I put it in my calculator. This time when I do 30 minus 24 over 7, I get a z-score, of 0.857, which I'm going to call 0.86. And now look up the associated p-value. 0.86 is 0.8051. If it had said less than 30 minutes, I could stop there. Because it said more than 30 minutes, I need to do 1 minus table value. 1 minus 0.8051 gives me 0.1949. When I get to number 13, it is a new question, it's a between question. But the good news is we already looked up 15 and 30 minutes. For 15 minutes, we got a p-value of 0.0985. For 30 minutes, we got a p-value of 0.8051. If I want to do a between question, I take the larger p-value, 0.8051, minus the smaller p-value, 0.0985. When I put that in my calculator, 0.8051 minus 0.0985 gives me my answer of 0.7066. If I look at number 14, there's two different ways to approach it. The first way, if I'm looking for less than 15 minutes or more than 30 minutes, is just to add together the two answers to the first two questions. So the first question was less than 15 minutes. It has 0.0985. The second question was more than 30 minutes. It has probability 0.1949. If I add those two together, 0.0985 plus 0.1949 would give me 0.2934. But there is another way to see it. The other way to see it is when I answered this between question, between 15 and 35 minutes. 15 was like here, 30 was here, we had our mean of 24. So this shaded area in between represented between 15 and 30 minutes. Really, the unshaded area here is the area that's less than 15 and the area that's more than 30. So if I work off the whole curve being equal to 1, the other way I could get to the same answer is I could do 1 minus the betweens, which would also get me to 0.2934. So with a question like this, either way is valid. Either I can individually find what's less than 15 and what's more than 30 and I can add them, or I can take the between number that I found earlier and do 1 minus that to find outside of the between numbers. For number 15, I haven't looked up either of these previously, so I'm going to need to start by finding two different z-scores. The first one is 20 minus 24 over 7. The second one is 25 minus 24 over 7. Again, I put these in my calculator in order to get the proper z-score that I can then look up in my table. When I do 20 minus 24 divided by 7, it gives me a z-score of negative 0.57. When I do it for 25, I get a z-score of positive 0.14. Now that I have the z-scores, I go to my table to look up the associated p-values. For negative 0.57, I get 0.2843. When I go to look up 0.14 on the other side, 0.14 gets me to 0.5557. When I do a between question, I take larger p-value, 0.5557, minus smaller p-value, 0.2843. When I put this in my calculator, 0.5557 minus 0.2843 gets me to my final answer of 0.2714.